Hi there, it's Blair here at Time Trades, and this is your converting time to price tutorial where I'm going to cover both planetary lines and planetary Gann pans, along with a number of other techniques that involve these scripts. Okay, so the whole concept here is we are employing different time to price conversions. So time in this case is represented by planetary longitude. You probably know that there's 365 days in a year and 360 degrees in a circle. So the planetary longitude of Earth is a very rough proxy for one calendar year. But why stop at using Earth for counting time? We also have the ability to easily and conveniently use other planets to count time, like fast planets like Mercury or the Moon, or slow planets like Jupiter or Saturn. And we also have the ability to make those slow planets appear to move faster by using different conversion techniques. So the core of all of this is simply counting degrees of longitude and translating that onto the price chart. I've already shared the basics of different ways to count longitude, whether it's geocentric or heliocentric or synodic in a prior video. So that is available to you. If you haven't watched that and you're confused by those terms, please go and get caught up on what that means. Okay, so converting longitude for price. There's two ways to do that. The first method is the simplest. It's called mod 360. It is basically where the user, you, define the price range of a complete 360-degree orbit of a planet or the moon. And then that price range is stacked vertically until it reaches the current price. So you can see in the screenshot there's horizontal bands of price, and vertical lines occur when the longitude laps or rolls around from 359 degrees back to zero. So the example in the screenshot here is Bitcoin trading at around $118,000. The user sets the scaling factor, also called dollars per 360 degrees of longitude, to $18,000. This means that the height of a single band is $18,000. So you can adjust this to the time frame that you're using. If you prefer lots of lines, then you should decrease the scaling factor to add more lines. If there's too many lines, then you should increase the scaling factor. That will space them out more. Also, if you're going all the way back and doing a lot of historical work back when Bitcoin was 10,000, then yes, you're going to have to decrease the scaling factor because the scaling factor today is certainly much too big for those historical prices. So this is pretty straightforward and easy to understand. You will notice there's two spots on the chart that kind of stand out. The first is the vertical line. That occurs when mirrored planetary lines cross 360 degrees. So you can see Mars in this case going up, going up, going up, hits 359, and then it reverts back to zero. Okay, and then it resumes going up again. Now, this spot over here is interesting where the lines cross. That is opposition. So what that is 180 degrees of travel of Mars heliocentric. That's where the lines cross. So you will notice that there is often reactions, price reactions around the conjunction or 0 degree mark and also the 180 degree mark. And when I say that, I don't mean like exactly on the day, I mean in the rough area of that. Okay, so that's mod 360. The second method is called the Wheel of 24, and this is described very well by Jean Long in her book, The Universal Clock. This is an original W.D. Gann technique, though. Jean really publicized it, and she was one of the original creators of financial astrology software. So the universal clock, or the Wheel of 24, consists of two wheels, one within another. The first is the time wheel, And this has, both wheels have 24 spokes. So there's 24 numbers arranged in a circle around this. And it starts at 1 right here, just above this thick horizontal line, and it ends at 360 over here. Okay. Now the outer wheel is the price wheel, and this also starts at 1, but it starts on the same spoke as the time wheel. So the price wheel starts at 1, and then it goes around just the same way as the time wheel. Okay. So the price wheel is always scaled at 1 degree of longitude per cell. The price wheel scaling can be adjusted. So this is where you come in. You can change the wheel dollar per cell value in the time trade scripts to match the price range of whatever it is you're trading, whether it's something with a very small price range or a very large price range. That will need to be adjusted from the default. Okay, so what happens is when a planet is at a given degree of longitude, a line is drawn at that price when the value correlates with the time wheel spoke. So for example, if we have, let's say, 243, a planet's at 243, then it's over here on the third spoke, okay? And on the third spoke, the line will go through any one of these prices that are on the price wheel, okay? But the bottom line is you don't need to know all of these details because the time trade software draws the lines for you. I think it's just important that you understand what's happening under the hood. Okay, so here's an example of the wheel of 24 and scaling it using the dollar per cell value. The user defines the wheel dollar per cell, and notice in this case it's not dollars per 360 as used in the mod 360 technique. So there are 24 cells in a lap around the wheel. So to match the mod 360 band height in our previous example, we calculate $18,000, divide by 24, and we get $750 per cell. And when we set $750 per cell, we get the same band height as in mod 360, okay? But what happens is these lines are a lot steeper because the lines travel their entire range in only 24 degrees of Mars helio movement instead of 360 degrees. So the lines become a lot steeper, and the result is we can make a relatively slow planet like Mars look a lot faster. And you can see how well it fits the price action here with this 24-degree boundary right here. The vertical lines occur every 24 degrees. We've got a 24-degree boundary right here catching the January 2025 high, okay? And also the opposition period, so this is halfway through this span of 24 degrees where the lines cross. That's 12 degrees of travel. It came within maybe about a week of the low over here in April, and then since then it's gone up quite strongly. Okay, so that is the basics of Wheel of 24 scaling. All right, now choosing the numbers. Okay, so there's a little bit of an art to this, and it's important to understand some of the fundamentals. Really, there's two scaling types, Unity and custom. Unity, when you're scaling using Unity, there's actually 3 different flavors of Unity. The first is where you set the dollars per 360 degrees to $1, 1 cent, 100, whatever. You can float the decimal wherever you want. That is a Unity scale, okay? Alternatively, $36.36, $360 per 360 degrees is also Unity. And then finally, if you wish, you can also divide by 2, and that provides a Unity scale as well. So $18, 18 cents, $180, etc. Now, these first three variants of Unity all apply to Mod 360 scaling. When you're using Wheel of 24 scaling, you need to take one of these three flavors of Unity and divide by 24 to get the price per cell. Okay, so this is how you can create the equivalent scaling using Wheel of 24. All right. The second overall type of scaling is what I call custom scaling. And this is using what I call Gann's big idea, and that is equivalence between price and time. So for example, if you're trading a symbol that has an all-time high of $33 and you want to scale using that, you can convert price to time, float the decimal, and use $3.30 per 360 degrees. So this is a way to convert between price and time and easily represent that important all-time high price in your planetary lines. Okay, so there's a couple examples of the screenshots here. The top one shows what I would call good scaling. So this is $750 per cell on the Wheel of 24. Where does $750 come from? Well, that's based on $18,000 per 360 degrees, which is Unity divided by 2. And then I divide that 18,000 by 24, and that becomes the price per cell value that I use when using Wheel of 24 scaling. The second example over here is what I would describe as suboptimal scaling, not so good. We're using $480 per cell on the Wheel of 24, and this equates to $11,520 per 360 degrees. And that is not any of the three flavors of Unity. Okay, so that should give you a good sense of how to make the most of the scaling values here. All right, so I'm going to talk a little bit about the planetary line scripts. Now, there's two types. There's unanchored planetary line scripts, TTPL. PL is short for planetary lines. Inner current, and current always means that it will cover the right side of the chart. So I update the dates in these scripts about once a year to make sure that the right side of the chart has data, and also that there's data for the next year. So we've got planetary lines inner current for the inner planets, planetary lines outer current for the outer planets, and planetary line inner/outer current for synodic angles or synodic longitudes, synodic cycles between the inner and the outer planets. The second type of planetary lines are planetary Gann fans, and these are anchored to a specific time and price. We have TTGF, GF is short for Gann fan, inner current, and TTGF, outer current. Now, there's a lot more detail in the user guide for details on what each script covers, plus additional scaling advice. So you can find the user guide here under More. Just go and click on More on the web page and click on User Guide, and then you can find it there. All right, so I want to give a few demonstrations now of everything that I talked about to help it sink in. So I'm going to show planetary lines, I'm going to show Gann fans, and I'm going to show a couple of advanced planetary line techniques around displaying lunar phases and creating Gann boxes out of planetary lines. Okay, so we're going to switch over to Trading View here, and I'm going to look up TTPL inner current, and this is one of the probably my go-to planetary line script, and it's complaining about something here, and we can adjust that complaint and deal with that complaint, because this is one of the things that happens when dealing with Bitcoin or very large data sets, is sometimes we get errors like this from TradingView and a little red exclamation mark. So by shrinking the amount of data on the screen, I was able to get rid of that red exclamation mark. And now I get a different error. It says number of lines exceeding the TradingView limit of 100 lines. So What this means is it's basically a scaling problem. It says, please choose fewer planets or increase the scaling factor. So that's good. We know how to work with the scaling factor here. First thing I'm going to do is demonstrate mod 360 scaling. We're going to increase the scaling factor here from 360 to 36,000. And I'm just going to focus only on Mars Helio. So I hit OK, and there we go. We've got our planetary lines on the script. So one of the things that we can do here is we can play around with the scaling factor. Let's say we want more lines, we can reduce it to 18,000. And then we get double the lines. And you can see how we get some very nice support and resistance levels when we do that, okay? Now, let's also take a look at the wheel of 24 scaling. So we're going to switch it over to wheel of 24. And $1 per cell is definitely not going to work for Bitcoin. And we get a little red exclamation mark here, as expected, runtime error, because we're getting way too many lines. We need to increase the scaling. So we know that 75 is basically the equivalent of 18,000. So if we go 18,000 for mod 360 and divide by 24, we get 750, not 75. I was wrong. So let's change that to 750. And now we get something equivalent to this unity scale. We know 18,000 is a unity scale, and 750 is the equivalent to that using the wheel of 24. And now we've taken our slow planet Mars, and we're applying a faster scaling technique, wheel of 24 to that. And now we get some very good hits on this, especially look at this little channel here coming down. Once price separates above that channel, that's a significant change in structure. So by applying these techniques, you can really get your structure dialed in. And then the new structure becomes apparent as it goes up here, probes below, goes back inside that structure the very next day. And then here we are here testing this upper line of this triangular cell. Okay, so very powerful technique here using the wheel of 24. All right, so let's switch it back to mod 360, and I want to show the Gann fans. So let's go back to Gann fans, and in the process, I also want to show the data window. Okay, one of the things that planetary lines does is it draws in the data window over here. So I get to the data window by clicking on this icon over here on the right. And there's a choice between object tree and data window. And I want to be on the data window because this is basically a little real-time ephemeris. So I can drag my mouse over and I can see exactly where all the planets are on that given day. Very powerful feature. So now what I want to do is let's anchor a Mars Gann fan using TTGF intercurrent. Okay, so we can anchor that, and we can start by anchoring it to, let's use this low over here. I like to use the closing low, so I'm going to use the close and not the low wick. Notice there's a blue prompt here that says set the anchor time and price for TTGF intercurrent. Okay, so this means that I have to click on the chart in order to tell the script where it's going to be anchored. Okay, so we've done that. And now we get some lines. They're very flat. They're not very useful. So what I want to do is I want to use Mars, and I want to use the exact same scaling factor that I used in the TTPL intercurrent script. And let's just use 1, okay? Because I want to just show how these work. Now, 1 is basically means that, so this is coming from this one here is coming from the planetary lines, and this line here is coming from the Gann fans. So I'm going to make this a little different color here. Let's make it pink, I guess. So the pink line is Mars, the Mars Gann fan. So these two lines are parallel, okay? Now, one of the things that I can do with the Gann fan script that I cannot do with the planetary line script is I can add additional rays to this. So for example, I can add a 1.5x ray, so it goes up 50%, well, 150% faster than the 1x ray. I can also add 50% ray, so one that goes up half as fast. You can see those here, right? And now we get some interesting hits here as the 150% Gann fan provides support over here on March 10th and also over here on September 12th of 2023, okay? So that's one technique, but I also wanted to call out and make sure that you understood how Gann fans are really the exact same thing as planetary lines, except they come from an anchor point in price and time. All right, so when it comes to setting the anchor point, you can set it to major pivots like I did here. Or another technique is you can anchor it to a significant astrological date. Like right here, remember when the lines cross? This is when Mars helio is at 180 degrees. So this is a significant astrological date as well. So what I can do is I can right click on the Gann fan and choose reset points. And now reset points will pop up the blue window down here and prompt me to reset the time and price for TTGF intercurrent. I'm going to set it right here to the close on the day after the 180 degree opposition of Mars helio. So now we've got our Gann fan down here. It's not interacting with price at all. That's not super useful. So we can adjust that by putting in some steeper lines. I can change the 1/2 multiplier, 3, 4, 5. We can basically go up until we get some lines that are helping us out. And look at this. So this is the 2x ray, and it provides some really nice support right here. These upper two rays provide a nice little channel here, again up here. And then the 3x ray provides support over here, and the 4x ray provides a little bit of support over here in June. Along with the planetary line. So that's one technique. Another one that I like to use is anchoring it to helioplanetary conjunction, okay? So this is where we can take advantage of the fact that the planetary lines show that vertical line where Mars helio is 0, okay? So I call that a conjunction. So that's really where Mars helio restarts its orbit. It's not really conjunct anything, but it's at the vernal equinox. So I can also go here and choose reset points, and I can reset it to, let's use this close here on the day after. And now we've got our rays coming out here. And you can see how they provided resistance and then support, and then resistance over here, and then support over here. So very powerful technique to make use of Gann fan intercurrent. Now, there's another way that you can anchor Gann fans, and that is taking advantage of the planetary line information here. So maybe you would like to anchor it, I don't know, just pulling numbers out of the air, to Mars 120 degrees. So that's 1/3 of the way through its orbit. So we look for Mars Helio here, and it's the fourth item in the data window, and scroll our mouse over and we look for the day when it hits 120, and it's here. Okay, right here on this high. Like a good trine, it makes a high. All right. And then the day after is when it crosses. There we go. So yes. So what we're seeing is the longitude on the start of the bar. Okay. So on this day, April 10th, it's going to cross 120 degrees. So again, I can go and reset points, and I can reset it to the close here. So this is the day when it crosses 120 degrees based on the data window. And then we can see how that encapsulates price very nicely. All right, so that's a demo of planetary lines and Gann fans. So that's kind of what I would call sort of basic use cases. Let me get into a few more slightly more advanced use cases. This next one involves creating basically 3 copies of PL intercurrent. And I'm going to start with a fairly wide mod 360 scaling of 36,000. Okay, so that's unity. And next, I'm going to add another copy of TTPL intercurrent. And I'm going to scale that to half of 36,000, which is 18,000. And I'm going to make that Mars. Okay. And of course, mirror lines is on by default. And in the first one, I'm going to make the line thickness 3, so I can see the important ones. And in the second one, I'm going to make the line thickness 2. And in the third one, I'm going to make the line thickness 1. And half of 18,000 is 9,000. And line thickness is 1, and we're going to mirror those lines. And now we've gone and created our planetary Gann box. So this is one technique. If you've seen Gann boxes online or in TradingView, you've seen them as kind of like static angles. Whereas this technique is creating a Gann box that is really based on planetary lines. Okay, so that's one thing that I wanted to share with you, and you can see here how we're right now. Price is in the middle of a bit of a congestion zone. There's Gann box lines from all 3 different harmonics. We've got the biggest harmonic up here at 124. We've got the smallest one providing some resistance over here at 121. And then the middle harmonic is providing some support. Okay, so you can see how that middle harmonic provided some great support over here as well in June. Okay, so that is the Gann box technique. Now, the last demo I'm going to show is how to use the moon-sun synodic to get a sense of lunar phase. So if we go back to our standby PL intercurrent, and we're going to bring up settings here. And now you'll notice there's 2 moons here. This first moon here, this is sidereal moon. This is tracking the moon relative to the background stars. So that's the 27.3 day cycle. This moon sun synodic over here, that is the 29.5 lunar phase cycle. So let's make this 36,000. We'll space it out. and I'm going to show you how we can basically take a look at lunar cycles based on this information. So remember, the vertical lines is where moon and sun are conjunct. So this would be a new moon. So vertical line equals new moon. So if you want to subdivide it into, let's say, eights, you can bring up, say, a fib time zone here, and we can start on this day and end on this day. Let's end on this day over here. There we go. And we've got a fib time zone that is basically drawing a red line every 1/8, okay? And then daily really isn't great for this kind of analysis. We can drop down to like a 4-hour chart, and then we can take a look at what that is telling us. And now we can see here at 50%, this is really the full moon area. We can see a nice pump up into full moon, and quarter moon preceded a dump, and then 3/4 moon preceded a pump. So this is a good way to visualize the lunar phases, however you prefer to see them. Maybe you prefer to see them as thirds, in which case you can easily do that. And now we've got lunar phase divided into thirds. And you can see this very clearly, how this move up started shortly after 1/3 of a moon, move up into full moon. And then after about 2/3 of a moon here, we got to move up into the next new moon. So that completes this demo, and I hope it gives you a very good sense of how to make the most of both planetary lines and Gann fans. Thank you so much for joining me, and I look forward to seeing you on the next tutorial. Bye now.